Pressure is force per unit area. It's a fundamental concept in physics that helps us understand how forces are distributed over surfaces. Whether we're talking about solids, liquids, or gases, pressure plays a crucial role in explaining many everyday phenomena. Pressure is defined as the force acting perpendicularly on a unit area of surface. In simpler terms, it tells us how much force is spread over a given area. The mathematical formula is pressure equals force divided by area. This relationship shows us that for the same force, a smaller area results in higher pressure, while a larger area results in lower pressure. The formula for pressure is written as P equals F divided by A, where P represents pressure, F represents force, and A represents area. The SI unit of pressure is the Pascal, abbreviated as Pa. 1 Pascal is equal to 1 Newton per square meter. This unit is named after the French mathematician and physicist Blaise Pascal. In solids, pressure depends on the contact area between surfaces. Consider the example of footwear. Sharp heels have a small contact area, which means the same body weight creates high pressure on the ground. This is why heels can damage soft surfaces. In contrast, flat shoes have a large contact area, distributing the same weight over a bigger surface, resulting in low pressure. This is why flat shoes are more comfortable for walking long distances. Liquids behave differently from solids when it comes to pressure. First, pressure in liquids increases with depth. The deeper you go underwater, the greater the pressure you experience. Second, liquid pressure acts equally in all directions at a given depth, not just downward. Third, the pressure depends on the density of the liquid. A denser liquid like mercury exerts more pressure at the same depth compared to water. Gases also exert pressure, and this pressure is exerted equally in all directions. Gas pressure is caused by molecular collisions. Gas molecules are constantly moving and colliding with the walls of their container, creating pressure. A common example is atmospheric pressure, which is the pressure exerted by the air around us. At sea level, atmospheric pressure is approximately 101,325 pascals, or about 1 atmosphere. Let's summarize the key points. In solids, pressure depends on the contact area between surfaces. The smaller the area, the higher the pressure. In liquids, both depth and density matter. Pressure increases with depth and varies with the liquid's density. In gases, pressure is uniform in all directions and results from molecular collisions with container walls. Understanding these differences helps us explain countless phenomena in our daily lives.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.